What we're going to look at is adding decimals together. So let's remind ourselves what a decimal is. 1.1 means that's 1 whole and 1/10. So therefore, if we're looking on our number line to place 1.1, we need to make sure that our number line is divided up into tenths in between each one. So there's 1 and there's 2, and there are 10 equal parts in between. So if I was going to locate 1.1 on the number line, that would be here. Now if we're going to add on 0.6, 0.6 is no wholes and just 6/10. So we need to move 6/10 to the right. 1, 2, 3, 4, 5, 6. And that gives us a new position, and that is 1.7. So 1 and 7/10 along the line. Rather than use the number line, we can actually just line up the numbers and add them down the page. So 1.1 will be lined up with 0.6, and we need to make sure that we're lining up each number with the right size number. So this is the units, the decimal points, and the tenths. And now if we add them together, just using normal addition, 1 plus 6 is 7, the decimal point is here, and 1 plus 0 is 1, so that's 1.7. So in this example, we have got two numbers which have got decimal parts to them. When adding them up, we need to line them up in the correct way. So 1.703, that's 1 whole, 7/10, no hundredths, and 3 thousandths. So when lining up the other number, we need to make sure that we have the matching sizes. So that will be there's 4/10, 8 hundredths, and there are no thousands. So you might want to put a 0 in just to sort of make everything the same size. Okay, and then we can just add up as normal. So 7 plus 4 is 11, so 1 goes down here and the rest of the 11 goes to here. 2, 3, 4. And so the answer is 4.183, which is written as a fraction would be 4 and 183 thousandths. We do the same thing when we're subtracting, making sure that each of the numbers is lined up in the correct place value. So 5.26, 5 wholes, 2/10, 6 hundredths, and we're going to take away 0.9. So we have to put the 0 units. The points are lined up so that we have the 9/10 lined up with the 2/10, and then we just subtract as usual. So you might want to put the extra 0 in here just to make it clearer, and we can actually then start the subtraction. 6 take away 0 is 6. 2 take away 9 you can't do. So we're going to borrow from the next one across. That's the whole number, so it's going to be indeed 4 of them. That means we now have 10/10. That makes a total of 12. 12 take away 9 gives us 3. And then we're at the decimal point. 4 take away 0 is 4. If we multiply a decimal by 10, what we have 2.7, so it's 2 units and 7/10. And multiplying by 10 means it's going to shift one place to the left because the 1 is going to be times by 10. So the 2 ones are going to become 20. And the 7/10 are going to be multiplied by 10, and that's going to become 7 wholes. So multiplying by 10 is straightforward. We just shift one place to the left. Similarly, if we multiply by 100, everything is going to move 2 places to the left. It's going to become 10 times bigger and then another 10 times bigger. So if we start off with 0 units, 1/10, no hundredths, and 3 thousandths, and we multiply it by 10, everything is going to move 2 places and become not 10 times bigger but 100 times bigger. So the 0 is going to move 2 places, and so is everything else. The 1 is moving 2 places, the 0 is moving 2 places, the 3 is moving 2 places. So the answer to 0.103 times 100 would be 10.3. Similarly, if we're dividing by 10, we're going to shift this, and this time the number is going to be 10 times smaller. So 58 would be 5/10, 8 units, the decimal point, and then 9/10. And we divide it by 10, everything's going to become 10 times smaller, so it's going to move one place to the right. So the 9ths are going to become 9/10, are going to become 9 hundredths, the 8 units are going to become 8/10, and the 5/10s are going to be 5 units, not forgetting the decimal point. So the answer to that will be 5.89. Now if we're going to try and multiply two decimals together, 6.2 times 1.3. What we'd first of all like to do is to make each of them a whole number. So to make 6.2 a whole number, the decimal point needs to move one place to the right. In other words, we need to multiply 6.2 by 10 to make 62. In a similar way, to make 1.3 into a whole number, we need to move the decimal point one place to the right. In other words, to make it into 13, so we'd also times by 10 again. So what we'd like to do is the calculation of 62 times 13, just using our normal arithmetic. What I'd like to show you here is some nice rectangular arithmetic, which makes things nice and easy. So 62 is just 60, and 2 is just 2, and that's going to be multiplied by 13, which is 10 and 3. And then what we actually do, we do 4 calculations, which are nice and easy, and then we add them all together. So 60 times 10. 6 times 1 is 6, and it was 60, and it's 10, so we had 2 zeros. 2 times 10 is 20. 60 times 3, 6 3s are 18, and there was 1 0, so we have to add that. And 3 times 2 is 6. So now we have 4 calculations which we add together, making sure that we keep the decimal place value lined up so that all the units, tens and hundreds, in the right place. So if we add these together now, we end up with the total, which is equivalent to 62 times 13. So that makes 10, 6, 7, 8. So our answer to 62 times 13 is 806. But if you remember, we started off by multiplying by 10. So now we need to reverse that action and divide by 10. If we divide by 10, the decimal point moves one place to the left. So this is a whole number. So we're dividing by 10, we end up with 80.6. But also, we multiply by 10 a second time. So we now need to divide by 10 that second time, which means we need to move the decimal place another place. So the answer will become 8.06. Now moving on to division. 7.2 divided by 12. We can just do our normal division sums. So how many times does 12 go into 7.2? We just have to remember to keep our decimal point in the same place in the answer. How many times does 12 go into 7? It doesn't, so that's 0, and we're now going to carry the 7. How many times does 12 go into 72? It goes in 6 times with no remainders. So our answer to the question, 7.2 divided by 12, is 0.6. The problem comes when we try to divide by a decimal. So a decimal divided by another decimal makes life a little bit more complicated. What we might consider is that division can be written like this, 12.75 divided by 1.5. And we can think of that as a fraction. What we need to do is to make sure that the numerator becomes a whole number. Notice in this earlier question, if we were dividing by a whole number, this didn't cause a problem. We were easily able to work out the answer. So we need to multiply up the numerator to make it into a whole number. 1.5 can be multiplied by 10 to make it into 15. So we can rewrite the denominator as 15. However, having multiplied the denominator by 10, we need to multiply the numerator by 10 to make it an equivalent fraction. So when timesing by 10, we move the decimal point one place. So that becomes 127.5. Now we have a calculation that we can do using traditional short division. So what we're saying, if we wanted to do 12.75 divided by 1.5, that is exactly equivalent to doing 127.5 divided by 15. How many times does 15 go into 1? None. How many times does 15 go into 12? None. How many times does 15 go into 127? 15 times 8 gives us 120, so we've got 8, and that's 120, so that leaves us 7 remainder. That's right, leaves us 7 remainder. So don't forget the decimal point is here, so put the decimal point here. And finally then we need to work out how many times does 15 go into 75. 15 times 5 makes 75, so the answer would be 5. So the answer to the question, 12.75 divided by 1.5 is 8.5. And we found the answer by working out an equivalent division problem.